Welcome to Argument Basics. In this short video, we'll be taking a brief look at deductive arguments. So deductive arguments, surprisingly enough, are arguments, which means that each one has a single conclusion, which is the point being argued for, what's trying to be proven, and it also has one or more premises, which are evidence being offered to support that conclusion. And you can have many premises. Now, the hallmark of deductive reasoning, at least as we define it in philosophy, is that the premises are intended to provide complete support for the conclusion. And intent here is important because there are arguments that succeed in this intent, and they're called valid, and there are ones that don't succeed in that intent, and they would be invalid. So another way to put this is that the premises, the evidence, is being offered as proof that the conclusion is not just true, but it must be true. This is also sometimes expressed as the conclusion is not supposed to go beyond the premises. That, in a sense, you're kind of drawing or extracting the conclusion out of the premises, so it's already kind of in there. And we'll see more of this. We'll get a few examples of deductive arguments. So how are deductive arguments used? What are they used for? Well, since deductive arguments purport to offer us certainty, if they're doing what they're supposed to, true premises are supposed to guarantee a true conclusion, they'll be used in cases where you can have and need or want certainty. Other uses are building kind of a logical framework where you establish some other points in, say, inductive reasoning, and then you plug them into a deductive argument because of that feature of certainty to frame your argument. For example, imagine someone is writing a paper about art, and they're writing about sexist art, and they present some inductive arguments that it's harmful, say looking at, claims by psychologists, etc., inductive reasoning here, and they establish that it's probably harmful. Then they could plug it into some deductive reasoning, like this. The first premise could be, if sexist art is harmful, then it should be censored. Then, as a second premise, they plug in what they've established with their other arguments, namely that sexist art is probably harmful, and they can conclude that it should be censored. Now, deductive arguments are not super commonly used in writing papers in most contexts for a variety of reasons. One of the main ones is, of course, it has to establish this certainty, and most of life is inductive. Now, how do you tell when you've got a good deductive argument, a valid one? Well, there are a few ways to do this. One is what's called the method of analogy. And one feature of deductive arguments that are valid or invalid is that they have these forms. You can think of them as like mathematical formulas. Like if you're familiar with the Pythagorean theorem, for example, an idea with like a theorem is if it's a theorem, if you plug in the right kind of numbers in the right context, you'll always get a right answer. And so a valid argument's kind of like that. It's a formula. If it's a valid argument, if you use that formula, it'll always be valid just because of the way the formula is. If it's invalid, it'll always be invalid. So if you recognize an argument of being a particular type, more on this a bit later, you'll know, aha, this is this type of argument, so it's valid. To use like another metaphor, if you draw a square, no matter whether it's a big square, blue square, etc., it's always going to have four sides. Why? Well, squares always have four sides, whether they're small or big or blue or whatever. And a valid argument's always going to be valid if you follow that structure. Another method is a fairly informal method, where what you do is you assume that the premises are all true, whether they are or not, and you ask yourself, if all these were true, could the conclusion be false? Now, this method is not super reliable because it's easy to be mistaken, to say, okay, this could be true, this could be true, this could be true, and oh, this definitely couldn't be false, because we may think the conclusion must be true because we want to believe it's true, and we or we have like some sort of bias. So just kind of doing this, not super reliable. Now, the best methods are using established formal methods. If you're dealing with what's called categorical logic, you would do Venn diagrams. There's also a rules method. If you take a class on logic, you'll see this stuff. There's also, for what's called truth functional logic, there's truth tables you can do. And there's also proofs, logical proofs. And doing those can show you objectively and definitely whether an argument is valid or invalid. So when you're doing this testing, to go back to our concepts, you're trying to see whether the logic is good and whether the content is good. So if you have good logic, it's called, for deductive argument, it's called a valid argument. And it's an argument such that if all the premises are true, the conclusion must be true. And this often throws people off, as I mentioned before, because people tend to think, oh, valid just means, true. But it doesn't mean that. It means if all the premises were true, then the conclusion must be true. And this will sound kind of weird, but you can have a valid argument in which everything is, not true. And you can have some that are quite, kind of silly. To give a silly example, if I say, think about unicorns. They're mythological creatures. They don't exist, but mythologically they have horns. So if, Star Fury is a unicorn, then Star Fury has a horn. Star Fury is a unicorn, therefore Star Fury has a horn. Perfectly good logic. Obviously, the problem is there are no unicorns, existing for real. So you can have perfectly good reasoning about things that are not true. Now, setting aside unicorns, think about doing math. If you were taking a class, say in business, and you are calculating a mortgage, you don't have to actually go and buy a house and have a mortgage to do the math correctly. You can just make up property values, make up mortgages, and do all your math correctly. Similar thing. Valid argument is like good math. And you can put in stuff that's not true. Invalid arguments are ones with broken or bad logic. It's an argument such that even if all the premises are true, the conclusion could be false. Now, people also get thrown off by this because they often think, oh, invalid, that just means false. But weirdly, though it may seem weird, you can have an invalid argument in which everything is true. To use a pretty silly example, take, say, 3 random true claims that have no connection. Like, I could say, like, I've got a Logitech keyboard, I've got which is true, premise 1, I have a Logitech keyboard. Premise 2, I have an Apple Watch, true. Conclusion, today is Tuesday, which is also true because today is Tuesday. Everything I said is true, but the logic is, well, there's really no logic there. And so even though everything I said is true, it's an invalid argument. In fact, it's so bad you might say it's not an argument. So what if you have an argument that's valid and everything in it is actually true? Well, in that case, it gets the exalted title of being sound. So valid, which means if all the premises are true, the conclusion must be true. And all the premises in a sound argument are true, therefore for free, the conclusion is true. So if you know an argument is sound, you know it's valid, you know all the premises are true, you know the conclusion is true, you know it's a argument. Now, unsound can happen in multiple ways. So if it's invalid, unsound. If there's one or more false premises, unsound. If both of these are happening, invalid, one or more false premises, also unsound. So if you know an argument is unsound, you don't know much definite about it. You know it could be invalid, could have one or more false premises, or both. So that's a quick run through of deductive arguments. Next, in our next exciting short video, we'll take a look at some common valid deductive arguments and some common invalid ones to see, examples of this, logical frame, this form stuff, and what the arguments actually look like, at least some of them. So see you in the future.